welcome to this lecture on adverse outcome pathways and their potential purpose for or what they can mean for environmental and radiation protection. My name is Nele Hans and I'm telling you this today because I am a researcher on radiation protection and environmental protection. I'm part of the team of the University of Hasselt, and I also work at the Belgian Nuclear Research Center, where I have a research group studying the impact of radiation on the environment. So before we start, we need to define what is an adverse outcome pathway. An adverse outcome pathway is defined as a conceptual framework that portrays the existing knowledge concerning the linkages between a direct molecular initiating event and an adverse outcome at different levels of biological organization and might be relevant to risk assessment. So that's a mouthful to say so, but important to remember is that an adverse outcome pathway tries to make a linkage to what happens at a lower level of biological complexity, subcellular, cellular, subcellular, molecular level, to what is an adverse outcome for risk assessment. An adverse outcome for risk assessment, for example, is population growth, morbidity, fecundity, reproduction. These kind of adverse outcomes can be linked by a pathway to what happens at the molecular level. As you can see, the definition of the adverse outcome pathway is quite recent. It's only 15 years ago that it was defined. So the knowledge and the way of using or building adverse outcome pathways is also something from the last decade and a half. Why would it be good or necessary to include the different levels of molecular complexity when you want to do risk assessment? Well, often the adverse outcome that you see is, for example, a change in reproduction, is not easily linked directly to the exposure of one or certain stressor. So that is one reason. Lower levels of complexity, the linkage to the exposure is more easily detectable. Often also the timing is different, so the molecular initiating event happens at an earlier time point than the change in reproduction, for example, and as such, you will be able to faster detect the changes in your ecosystem or in the population that you're studying. Also, the sensitivity of molecular initiating events of lower endpoints at lower levels of biological complexity is higher, meaning that at lower concentrations or lower dose rates, you will already see a change in the molecular initiating event, whereas the change in reproduction only happens at higher dose rates or concentrations. So different levels of biological complexity, I have already mentioned it a few times. So normally, if we look at ecotox tests or at what happens in the lab, often the individual or one organism is studied. So for example, the endpoints that I mentioned, like reproduction or growth, that is done at the organism or population level max. Whereas what you want to protect. For the human, it is the organism, each individual you want to protect, but for the ecosystem, you want to, or for the environment, you want to protect the population or the ecosystem. So environmental protection standards are at a higher level, they are at the population level or the ecosystem level. As said, the lower endpoints, the lower levels of biological complexity, the organ, cellular, and molecular endpoints, they will pop up earlier, they're more sensitive, and they are better linked to the pollutant as such. So the adverse outcome pathway is a way to link what happens at the molecular level to what happens at organism or population level. The adverse outcome pathway framework has different purposes or different applications, if you can say it like this. So they provide an approach to hazard characterization. They also are able to identify knowledge gaps, priority areas for research. For example, if you see that there is really a knowledge gap, you know that is the way to go for. They might also, and that's especially for quantitative ones, they might also be a way to detect new biomarkers or bioindicators, not only for radiation protection, but for any environmental stressor. They provide mechanistic understanding and also a way for more mechanistically informed risk assessments. They will identify certain uncertainties in toxicity pathways, and they, as such, can also improve our understanding in multiple stressors. So if an organism is exposed to more than one stressor at a time. So in a way, adverse outcome pathways can also be a tool for risk assessment and research. Although for being able to use them in risk assessment, you need to link not only the pathway to the toxicity, but also to the dose or the concentration. And that functional relationship is only, as we will see further on, present when you do a quantitative AOP. Adverse outcome pathways, there, as I said, it's only around 50 years ago that they were first defined. There is an international group from the OECD, for example, that tries to gather all the different adverse outcome pathways together. There is something like the AOP Wiki where you can do that. It's a collaborative development of AOP descriptions. And also a way when once you have a description of your AOP and you go to prove the different steps in that AOP, this can also be formalized by a working group that is working behind the scene of the AOP Wiki, and that will make from a conceptual AOP a real formal AOP that you can then take further and to a quantitative AOP. There are also different guidelines on the AOP Wiki, but are also available on the World Wide Web on how to start with an AOP, how to build them from scratch. If we go back to the history of the AOPs, as I said, it's only the last 15 years that AOPs are really being developed. It's 10 years ago, in 2014, that the OECD Users Handbook, the first edition of it, came available. Now it's already the third or the fourth edition from it, and you can find this one at the AOP Wiki. So what is an AOP? An AOP is a kind of a simplified toxicity pathway that starts with a molecular initiating event. This molecular initiating event is normally at the level of is a molecular event, but can also be a subcellular event, for example, ROS production. And then from that, you have different steps that lead until that changes the adverse outcome at individual or population level. Typically, the adverse outcome pathway will start at a lower level of biological complexity and will gradually go from molecular to biochemical to subcellular, cellular, organ level, and so on. So an adverse outcome pathway has different building blocks. The first being the biggest chunk of it are key events, and actually the molecular initiating event is a specialized key event. It's the first trigger of your pathway, and one says that once the molecular initiating event is switched on, from that way onwards, the whole adverse outcome pathway normally will continue to happen. In addition to the molecular initiating event and the key events, then you have your final building block, which is your adverse outcome, which can be either at the organism level or at the population level. In between these building blocks are the key event relationships. They are the causal relationship from when a downstream state of a key event will change into an upstream key event. Life is never simple, nor are adverse outcome pathways, and often you will see that in real life it is not an adverse outcome pathway, it's not a linear link, but can be more complex, and it can form real networks where different molecular initiating events will lead to a similar adverse outcome, but through different pathways. The key principles or assumptions of an adverse outcome pathway: in the first place, an adverse outcome pathway is not stressor specific. It's specific to the molecular initiating event, but this molecular initiating event can be triggered by multiple different stressors. The second one, we already talked about that one, is that adverse outcome pathway is always modular. It is built, it are the building blocks, the different building blocks that make up the pathway. You need a minimum set of causal building blocks to form an AOP, so you cannot say a molecular initiating event and an adverse outcome. You need a minimal causal event to start from the molecular initiating event, crossing the different biological levels of complexity up until the organism or population level. On the other hand, adverse outcome pathways are also pragmatic. They don't go and look at all the different small molecules, switches, changes in proteins, and so on. They take the bigger pragmatic molecular initiating events and key events to build as building blocks. And finally, they're living documents. So if you submit an AOP in the AOP Wiki, it is looked upon by the by a group of people, by a group of experts, and these experts might suggest you to go dig deeper in the literature and maybe change the AOP a little bit, or you can yourself find additional evidence and add this one also to the AOP Wiki, for example. As such, the AOPs are living documents at the AOP Wiki. The strategy, how you will start? You will start normally by going into the literature and by finding a toxicity pathway, whether it's already a known or whether it is a more conceptual unknown pathway. And you will try to get that toxicity pathway changed into an adverse outcome pathway. The difference is that for the conceptual adverse outcome pathway, you really select what are the most pragmatic different building blocks that you have. And you really span from the molecular initiating event until the adverse outcome. Once you have your concept and you have added it to the AOP Wiki, you will try to get it formalized and try to get the weight of evidence into that one. And then finally, to get from a formal AOP to a quantitative AOP, you need to look at all the dose-response relationships between the different key event relationships. Meaning that you will say at this point the pathway will go through to the next step. So a conceptual and a formal AOP, they look like this. We have already seen it. Their key features are that they are stressor agnostic, so unspecific for a certain stressor, modular, a minimum set of causal events, and they're pragmatic, as I said. You will start, as I said, with a scientific review, most of the times it's a literature review. Sometimes you will add some of your own experience or your own lab experiments to it, and you build this conceptual AOP. You will then start to look at the experimental evaluation of that AOP. You want to see, for example, you want to see that all the dose-response curves from the molecular initiating up until the adverse outcome pathway follow one after the other. Meaning that if you look at one response of effect, for example, 50% the EC50, the 50% effect level, you will see that at a lower dose rate for the molecular initiating event compared to the key events. Also at an earlier time point and at a lower level of biological complexity. The weight of evidence building is needed in order to have it submitted as for review and to get it formalized into a formal AOP. An example of a conceptual AOP for radiation protection, we say that the molecular initiating event for radiation is often called the deposition of energy. This deposition of energy leads to, for example, an increased oxidative stress, an increased production of reactive oxygen species, which will lead to endothelial dysfunction, which can then lead to vascular remodeling and to cardiovascular diseases. The cardiovascular disease is the adverse outcome for humans at the human level. Another example is kind of a network that was done for multiple different organisms, again for radiation, gamma radiation, and the adverse outcome looked at here is a change in reproduction. And you see that for the different organisms that we included in this multiple AOP network, we had primary producers, algae and macrophytes. We had some worms, including C. elegans and earthworm. We had Daphnias and some other smaller organisms, and we had higher organisms, the zebrafish mainly. We were able to get this pathway, and you see that for some levels we had to make a distinction between what happens for certain of the organisms and what happens for other organisms. So the weight of evidence building, as I said earlier, that is the where you look at either the differences in the dose or the concentration between the different key events, the temporal differences, and the incident differences, meaning that for the dose, for example, normally a lower stream key event, so downstream key event, will pop up at lower concentrations compared to an upstream key event. Temporarily, a downstream key event A, will pop up at an earlier time point compared to an upstream key event, and normally at the same concentration you will see a higher effect, for example here in EC50 in key event in a downstream key event A, compared to an upstream key event. Additionally, one weight of evidence that is looked at is whether or not a key event is essential for the pathway to continue. What you see here is an population decline for primary producers at a conceptual AOP, where you see that the weight of evidence indicated as smaller circles with color coded, low for low weight of evidence, and green, red for low weight of evidence, and green for high weight of evidence for the different key events and key event relationships. So once you have your conceptual AOP, you've done your weight of evidence, and you got your AOP formalized, you can continue to gather information on the dose response curves and the different key event relationships and try to build a quantitative AOP. For a quantitative AOP, you will quantify additionally to what you already have. You will look at the uncertainty, and you will try to make to quantify the functional relationship between the different key events that are in your adverse outcome pathway. For this, you will try to find experimental evidence, the dose response curves, based on both the doses and the time, and you will try to see when a certain dose response curve will start to happen. What is a point of departure, both at what concentration and at what time point? This is an example recently published by Song et al. For the gamma radiation of Daphnia, where they looked at data coming from different levels of biological complexity, including the transcriptome, metabolome, and the phenotypical changes. And they, for each of the different endpoints that they had, they looked at when there was a point of departure, what concentration and at what time point you would see the dose response curve start off. All of that information is then gathered in the AOP, and it are the gray building blocks that you see in this slide that will make up these key event, these functional relationships for the key event relationships. It says, for example, at what dose rate in this case you will move from this key event to the next one. How can we then use all of this new information? Well, actually, what a quantitative AOP has on top of a formalized conceptual AOP is that it does not only look at a hazard assessment, but also looks at the dose response assessment. And if you know a little bit about risk characterization and risk assessment, you know that for a good risk assessment, you need the linkage between the dose response curves and the hazard assessment. If you have that linkages, you can characterize when an organism is at risk, and as such, you can start using it to predict the exposure in a population or predict the harm, the risk of a population or an individual organism if that is your adverse outcome. So you need these key event relationships, the functional relationship of the key event relationships. You need these to be able to link it to the dose response and to link it to risk assessment. So if we conclude a little bit, our adverse outcome pathway is a framework that has different purposes and applications. It can be used to enhance the use of the mechanistic data available, that it can also look at the uncertainties of certain adverse outcome building blocks, so the different key events. It can make hypothesis-driven or it can be a way to build the hypothesis for hypothesis-driven testing. It can do cross-species extrapolation. Think about the adverse outcome pathway network that we had for the primary producers, the worms and the fish. It can evaluate complex mixtures. I didn't show a real evidence for that. And it can start to be a way for risk assessment. It can be a risk assessment tool if the functional relationship of the different key event relationships is known, linking it functionally to the exposure. So that is only possible for a quantitative AOP. What does an AOP framework does not do? It is not the synonym for a high throughput pathway. It is not a way to analyze the mode of action, although information of the mode of action can become available from it, and it is not a computational model. Finally, I would like to say that in 2021, we did an International Horizon style exercise where we looked at all the challenges that we thought would be perceived for AOPs, specifically for AOPs in the radiation protection community. And we ended up with a number of mechanistic themes that the community or all the participants, more than 100 participants that we had, through answering 257 questions, came up with as the mechanistic themes that we need for adverse outcome pathways within radiation protection. I would like to conclude here. I hope you learned something on adverse outcome pathways. If you look for more information, I can tell you that a lot of the basic knowledge on the adverse outcome pathways is present at the AOP Wiki. It is looked at by the OECD. Also, there are different working groups. Here I mention the NEA OECD high-level group on low-dose radiation, which did the horizon style exercise, but there are many working groups looking at different AOPs. If you want to reach out for me, you can reach me at, you can look me up at the Belgian Nuclear Research Center, SEK-CEN, and I would like to thank my PhD student Luca Boldrini, who is building AOPs as we speak. And I would also like to thank Knut Erik Tollefsen. Knut Erik Tollefsen is from a Norwegian institute NIVA. He gave input to these slides. Part of the slides were his. He also guided the AOP reproduction working group that came up with the AOP network that I discussed earlier. And I learned a lot about adverse outcome pathways from Knut Erik. That's it. I hope you learned something, and as said, if you want to contact me, please try to find me.